Alright everybody, so here is a follow-up to the last video. We talked about the tangent line to a curve. I drew you some pictures, we did some problems, and this is just part 2 of that. Uh, where I want to play off of the same concept of what a tangent line to a curve is, but do some of the harder problems from the lesson. Or at least problems that are similar to the more difficult ones. But since it's right here, I'll go ahead and remind you. What is the tangent line to a curve? Well, the curve is the graph of some original function. And in red there, you see the tangent line to the curve at some specific point. Okay? In the defining features of the tangent line is that it meets the curve at one and only one point. And at that point where they meet, they're indistinguishable from each other. You cannot tell them apart. And what's that mean if I say right there at that point they're identical, just like you can tell there? Do you see two things? Do you see the curve and the tangent line? They should blur together, right? You can only see one thing right there. You zoom out and that's not the case, but yeah, right there at the point, they're essentially the same. And by me telling you that, I'm just trying to say that the slope of the curve at that point is the same thing as the slope of the tangent line at that point, just like you see in the picture. Okay? All right, so let's take an example to play off of that theme. Okay, so let's say that we want to do this. We want to locate the point or points, if there's more than one, on the curve y is equal to negative x squared plus 1, where the tangent line would intersect the point 0, 5. And then I give you a hint because I told you that I would tell you what the derivative is. That y prime for this curve, the derivative for that curve is negative 2x. Okay? All right. So there's a lot to unpack and think about in the question. So what I thought I would do is summarize it all in a picture. Okay? So here's a way you could think about what that question was asking. You got the curve right here. And somewhere on the curve, if you draw the line at some point that we're going to find, the tangent line from there will intersect the point 0, 5 on the y-axis. So there's the curve, there's the tangent line at this point, unknown place, and that tangent line intersects this point. All right, it's all in the picture. Okay. All right, so here's how we can do it. First of all, I need a name for that point. If I want to say, where is this point? If I'm going to do any math with it, I need to label it. So I'll go ahead and I'll say this point is x and y. And why would I call it that? So I don't know what it is. I don't know the x coordinate. I don't know the y coordinate. If I did, I'd have the answer. All right? So anyway, here's the way that we can do it. Okay? We can use the fact that there's two ways to measure the slope of this tangent line. Okay? One, I could say the tangent line has a slope that's equal to the slope of the curve, which I could find by the derivative. But it's also equal to the rise over the run between those points. Okay? All right. So let's think of it like this. We'll get like kind of an equation that summarizes that. All right, the slope of the tangent line that you see right there is equal to the rise over the run that you see right there. Oh, sorry. The slope of the tangent line that you see right there is equal to its rise over its run, isn't it? Because that's the slope of any line. But how do we find the slope of the tangent line? We use the derivative. Okay. So let's do like this. We'll say, okay, what should the slope of that tangent line be? Negative 2x. Okay, so negative 2x. But what, as you're looking at it, what's the rise and the run? Okay, well here's what I mean by that. See this tangent line right there? The way it's constructed? Here's the rise, and here's the run, right? Okay, so yes, what's that? Well, that would be 5 minus y, that's the rise, over 0 minus x, that's the run. Okay. So it was just, our equation is two ways of talking about the same thing. The slope of the tangent line can be found by the derivative on one hand, but it can, because it's a line, it can also be found by the rise over the run. And I have both of them. This rise and run, though, corresponds to it going through those 2 points. Okay? All right, so that's the concept. Now, I need to solve this equation. If I can solve this equation, then that will take me to where this point is. All right, so let's see if we can do that. Well, there's nothing I can do with that yet. This thing right here, well, that has two variables in it. It's got a y and it's got an x. And the y came from this point having some unknown y coordinate. But is that y coordinate on this curve, is that entirely unknown? What's the equation? Oh, so that curve right there has an equation. Y is equal to negative x squared plus 1. I do have a way of putting the y coordinate in terms of the x, and that's what I need to do. So I need to say 5 minus the y coordinate of that point, being that it's on this curve, is negative x squared plus 1. Okay, and then over 0 minus x. And then that's an equation that has only one variable in it, and I can solve it. So let's see, negative 2x. All right, we'll do a little subtracting here. We'll get 5 plus x squared minus 1 if we distribute that negative. Here, this will just be negative x. All right. We'll combine some like terms. We'll get negative 2x. We'll get 5 take away 1. That's 4 plus x squared. And then over negative x. Say we multiply both sides by negative x. Then I'll get 2x squared is equal to 4 plus x squared. And then if I subtract this, subtract x squared, I'll get x squared is equal to 4. And then that will give me two answers. That will give me plus or minus 2. 2 squared is 4, but negative 2 squared is also 4. Okay? There's two answers then. There's 2 and negative 2. How could that be? Well, as I've drawn it, like with this graph being, roughly of the right shape and scale and so on, that point can project a tangent line and hit 0, 5, but there's going to be a point over here too that does the same thing. Okay? And those points have coordinates for x being 2, the one on the right, and negative 2, the one on the left. All right. So anyway, give my final answer. So I know there's a point over here at 2 for x, and then 1 at negative 2. But to give you like an answer for points have an x and a y. So let's give our answer this way. Okay, so final answer to the question. Where is that point? It's at 2 for x, and being that it's on this curve, what's the y coordinate? Well, you find the y coordinate right out of this equation. Negative 2 squared, so that's negative 4, plus 1, that's negative 3. All right, so 2 for x, negative 3 for y. And then remember, there's 1 on this side too. It's a negative 2 for x, okay? So, and negative 2 for x, negative 3 for y. That'll be the other point. And I know that it doesn't look like that point has a negative y coordinate, but the picture is here not to be totally accurate in scale, but just to explain all the information in the question. All right, but nonetheless, we got a point over at 2, -3, and -2, -3. All right, we got 2 answers, 2 points. Okay, so that's how you do that one. And like I said, I think that one's probably one of the more difficult ones. There's another, this is, I think, maybe one right out of the lesson. There's a similar one to it that you can try now. So let's look at one more of the more difficult questions. Okay, consider the curve f of x is equal to 2x squared. And take the tangent line to that curve at the point where x is -1. At what point does that tangent line intersect the line y is equal to 2x minus 4? Hint about the derivative to that, because I told you for now I give that to you. The derivative is 4x. Okay. Now, I think this one, like the last one, there's a lot to read and understand, and you have to understand everything that's involved and how it connects together. But I've summarized that in a picture. Okay. So here's the curve. There's the point of interest where x is -1. Here's the tangent line to that curve at -1. And where does that tangent line hit this other random line that's somewhere else? So there's everything in the question, and we're just after the location of that point right there. Okay? All right, so let's do the breakdown for this one this way. First, I think I'd have to find the equation of that tangent line. I can't figure out where it hits or intersects this line unless I know what the equation is. All right, so let's say first thing, what is the equation of that tangent line? Okay, and remember the breakdown for that was that 1, it's a line, and so it will have equation y equals mx plus b. First, we'll find the slope. Okay? What's the slope of the tangent line? Okay, and we use the derivative to find the slope of the tangent line to a curve. The derivative for this curve is 4x. So the slope at the point where x is equal to -1 is going to be f prime of -1. All right. Okay, and then f prime is 4x, so that'll be 4 times -1 or -4. All right. So then we get a partial answer to what the equation of the tangent line is. Okay. So my partial answer, being that it has a slope of -4, is that it's y is equal to -4x plus b. All right. Okay. How do I find b, though? That's the one last thing to find. Well, the way I've showed you before is that you can take a point that you know is on the tangent line and put that in for x and y and then solve for b. So we'll think of it like this. So see this point over here? Earlier I said, well, that point has an x coordinate of -1. But I could have told you more than that. I could say that point is, sure enough, -1 for x. Is there any way you could tell me the y coordinate? Well, there's the equation for the curve. You plug the x in, you get the y back out. You'll get 2. Okay? The y coordinate's 2. So the tangent line has that point right on it. You could put this for x, that for y, and it would be valid because that point is on there and you can find b. Okay? So we'll put 2 for y, -1 for x. So 2 for y, -1 for x, and then b is the only thing left at that point, and we can figure it out. So we'll get 2, we'll get 4, plus b, right? And then we'll move the 4 over, we'll get b is equal to -2. So the tangent line has this equation. I'm gonna write it on my picture up here. The tangent line, that thing in red right there that you see, that's gonna be y is equal to negative 4x minus 2. Okay? All right. So now our question breaks down to this. Okay? It's all reduced into this. This line right here, the tangent line, that has equation negative 4x minus 2, will intersect this line, 2x minus 4, at that point. Okay? So let's do like this. I'll say, do you see this point? Yes. You can find this point of intersection by just setting these equal to each other. That will take you to the point they meet at. So we'll take 2x minus 4, and then we'll set it equal to this other one, negative 4x minus 2. Okay, we'll solve that. If I move the negative 4x over, I'll get 6x. If I move the 4 over, I'll get 2. And then I'll get x is equal to 2 over 6, but that's 1 over 3. So, okay, then it looks like we've got most of our answer. The x-coordinate of that point right there is a third. All right, this point is a third to the right, and then like so many units down. Okay, so how about this? I want to put my final answer like this: 1/3. That is the x-coordinate of that point. Where is this point? 1/3 for x. What about the y-coordinate? Well, we could figure it out from this, right? You see that line right there? That point's got an x-coordinate of 1/3. What's the y-coordinate? Put 1/3 in, you'll get it. You put the x in, you get the y. So I'll get that y-coordinate by doing 2 times 1/3 minus 4. Okay? All right, that's how it's going to work. So, all right, this is going to be 2/3 minus 4. So that's going to be 2/3 minus 12/3. So I'll get negative 10/3. All right. So that point, it turns out, where is it? It's right 1/3. It's down 10/3. And we've got it.